Hey boys and girls, so today we're going to be going over lesson 3, which is inscribed angles, central angles, and their intercepted arcs. All right, so if we look at the do now, it says given circle C with diameter AB. Question says how many degrees make up a full rotation of a circle? So I know, just like you guys know, that if I wanted to go all the way around the circle, I would have to travel 360 degrees. And again, there's 360 degrees in a full circle. If I look at part B, it says how many degrees make up half of a circle, so half a rotation. And you guys know that for me to get from, let's just say A to B, so if I just want to go half that circle, well, half of 360 is 180. And then again, 180 degrees is for half a circle. Another way of saying that would be a semicircle. So this might be a new vocab word for some of you, but you got it. All right. So if I look at the vocab words underneath, these are going to be really important for today's lesson. So the first one is an arc. I'm just going to highlight that here. So I know an arc, it's really just a portion of the circle, okay? I know that the keyword circumference is here, so it's just telling you that when I'm looking at that portion of the circle, it's going to be on the edge of the circle. That's the portion that I'm looking at. All right, so if I wanted just B to C, it would be on the circle. It would be just that little chunk that I'm looking for. Same thing, CD, it's just that one chunk that's on the circle. It's part of the circumference that I'm looking for. All right, so those would be arcs, BC or maybe CD, all right, because they're sections of the circle. Next, we see a minor arc. So minor tells me that it means less than 180 degrees. So it's talking about these arcs. It's an arc, so like BC, that measures less than 180. So this is obviously less than half a circle, so this would be a minor arc. A major arc is the opposite. A major arc is a portion of the circle that's greater than 180 degrees. So in order for me to get from B to D, I could either go from top to bottom on the right-hand side. That would be a minor arc because it's just a small portion of the circle. Or I could go from B all the way around to D. This would be a major arc from B to D because I'm obviously traveling more than 180 degrees. All right. If I look at number 2, it says given circle A, this is new, that's the arc symbol. So I know that arc BC is 25. And it's important that you follow the order of the letters. So if it's 25 degrees, for me to get from B to C, it should be a tiny portion of the circle, and it is. Same thing, arc CD is 35. So from C to D is 35 degrees, and I'm just going to mark that. And then if I look at part A, it says, what is the degree measure of minor arc BD? So if I want to know minor arc BD, well, to get from B to D, I have to travel past both of those numbers. So 25 and 35, when I put them together, give me 60 degrees. So that would be the length, or the degree measure, I should say, from B to D. All right, now if I look at part B, it says, what's the degree measure of major arc BD? So just like we had gone over before, I can either follow B to D on the right and get my minor arc, or I can follow B to D going to the left and get this huge major arc, okay? If I know that this portion in yellow, let me just highlight that again. This portion in yellow, part A, was 60 degrees. I know that a full circle is 360. So if I take the whole circle and subtract out the yellow, which was the 60, I'm left with the green, that BD, that major arc that I wanted, which was 300 degrees. All right, and then I'm just going to go ahead and label that on my diagram since I found it. So this is 300, add it to 35, add 25, and together you make 360 for the whole thing. All right. If I continue reading at the vocab down below, These are, again, just important vocab words that I need to use for today. So an intercepted arc is an arc that's formed by an inscribed or central angle. All right, so this entire definition is huge. Let me just highlight the vocab word, intercepted arc. And it's an arc that's formed by an inscribed or a central angle. Okay, and now you're probably asking yourself, well, what is, an inscribed or a central angle? Well, here they are down below. So an inscribed angle is an angle whose vertex is on the circle. So this vertex is on the circle, right? Point B is on the circle, and it's formed by two chords, all right? So AB and CB, right? Those are chords, all right? An inscribed angle is going to be half the measure of the arc that it's hitting. All right, this is very confusing. I know there's a lot going on here, so let's do a quick example. If I know that the length or the degree measure, right, of AC, let's say that length was 50 degrees, all right? That means that angle B, because it's an inscribed angle, it's going to be half the measure of the intercepted arc. Well, I can see that this inscribed angle is formed by these two chords, right? And these two chords are hitting AC. So if AC is 50, well, what's half of 50? You got it, it's 25. So I know that this inscribed angle would be 25 degrees because it's half of the arc. Now, if I look at a central angle, it's different. So a central angle is an angle whose vertex is at the center of the circle. Just like here, this angle is at the center, and it's formed by two radii. So the center to the edge, center to the edge. It's formed by these two radius, okay? And a central angle is going to equal the measure of the intercepted arc, okay? So I can see that AC, I'm just going to bring it down, right? If it was 50 up top, I'm going to keep it 50 down below. So I know the degree measure of AC is 50 degrees. I know that this central angle at O is formed by OA and OC. Okay, and these two radii are hitting the 50. Well, I know that the angle will equal the arc. So if the arc is 50 degrees, I know that the angle is also going to be 50 degrees, all right, because they're equal. If you're ever unsure of what arc your angle is hitting, just do what I'm doing, guys, and just try to highlight out the angle itself, and you'll see what two letters it's intercepting. Where am I? Intercepted arc. All right. So one more time, an inscribed angle is on the circle, and a central angle is at the center of the circle. All right. Questions, comments, concerns? Okay, let's go to the next page. Flipping over. Oh my gosh, so much to go over. Okay, so this question looks pretty long. It's actually pretty simple. It's just asking us to now identify all of the different vocab words that we just learned on the first page, all right? So if we look here, given circle A, I now want to go over what all of these are using the vocab on the previous page. Okay. Part A asks me to look at arc BE. So if I look from B to E, because again, let's add this to our notes real quick. It's so important that you follow the order of the letters. Okay. If I follow B to E, this is definitely less than 180. It's maybe like 1/4 of the circle, right? It's just a little chunk. So I know that this isn't just an arc, it's a minor arc. All right, and then I'm just going to fill that in. If I look at part B, C, D, E, go in the order. C, D, E. Whoop. So if I want to make my way from C to D to E, I can see I'm looking at this bottom half of the circle. So we went over on the first page that half a circle is really considered a semicircle. All right, part C. Go in the order of the letters, E, D, F. So I'm looking at that arc on the circle, E, D, F. Isn't that type of music that you guys listen to? Oh, no, maybe, what is that, EDM? Oh my gosh, I'm so old. Okay, E, D, F. So again, this is obviously less than half a circle. So if it's less than 180, it's a minor arc. And then if I look at part D, Fed, arc, F-E-D. I need to get Fed. F, whoop, E, O. And then I have to go down for D. So that doesn't make any sense. So I must have to go the other way. So I can't just move from F to E going to the right. I have to go to the left. So F, whoa, E, whoop, D. So F, E, D. I have almost the whole circle here, guys. So that's definitely not a minor arc. That has to be a major arc. Okay? That's why it's important. Go in the order of the letters. All right, and then I'm just going to stop for a minute and I just want to label the first four. These all had the arc symbol, so I know that I should be looking at arcs for those examples. Then if I look at EFG, these all have angles, so I'm going to look inside the circle now to answer those questions. Oh my gosh, angle bay. Okay, angle BAE, BAE. So I can see this angle is being formed right at the center of the circle, which means it's not just the center, it's the central angle. All right, so central angle. Next, BDC, BDC. So this is an angle that's it's on the circle, right? We always look at that letter in the middle, kind of tells us where to go. So this was the center, so it's a central angle. This is on the circle, so it's an inscribed angle. And then last but not least, ECF. So again, following the order of the letters, ECF. So again, this is an angle that's on the circle, which means it's inscribed as well. And again, just because they had those angle symbols, I know I had to use the angle vocabulary here. All right. Now, if I look at example 2, it says, given circle A, again, A is the center, that's why we're calling it A, determine the measure of angle BAD, B-A-D. So if I go in the order, B-A-D, oh my gosh, it's a straight line. How many degrees are in a straight line? 180, you got it. So I know it's 180 degrees because it's not just a straight line, but it's considered a straight, you got it, a straight angle. Oh my gosh, is my pen running out of ink right now? I hope not. Whoop, okay. Part B is now saying determine the measure of angle BCD. BCD. All right, so there's kind of a lot going on here. I can see that BAD is not just considered a straight angle, it's a straight line, right? It's going through the center, you got it? It's a diameter. So I'm just gonna label that for our notes. But if you remember from lesson 1, and it also came up in lesson 2, if the diameter of a circle is also a part of a triangle, it's not just a diameter anymore, it's also considered a hypotenuse. And what is the hypotenuse across from? The 90-degree angle. Okay, so you've seen this in lesson 1, most of lesson 1, right? And then some of lesson 2. So if I look at part B again, it says, what's the degree measure of BCD? Well, BCD has to be 90 degrees. And again, I know it's 90 degrees because the diameter is a hypotenuse here. I am running out of ink. Oh gosh. Okay. And then part D, it says name all the inscribed angles. So if I'm inscribed, that means I'm on the circle. So I'm just gonna highlight that because it's a new important vocab word. So I can see that angle B is on the circle, angle D is on the circle, and angle C, right, is on the circle. So I'm just gonna go kind of right around here. So if I start with angle B, I'm gonna call it angle C, B, D, right? B is in the middle because that's the angle itself. Next, I'm going to label D. I'm going to call it angle C, D, B. Again, D is in the middle because that's where the vertex is being formed. And then last but not least, I got to label my 90-degree angle for C. So I'm going to call that angle B, C, D. And again, C is in the middle because that's where the vertex is being formed. All right. So now if we look at example 3, it says in circle A, there's kind of a lot going on here. You know what, give me 2 seconds, guys. I just want to quickly grab another pen. Okay. So it says in circle A, we have arc BC is in a ratio with arc CE, and that's in a ratio with ED, and that's in a ratio with DB. So there's kind of a lot going on here. And it's saying that the ratio is 1 to 2 to 3 to 4. All right, before I even keep reading, this is a refresher from the last unit. Anytime you had seen a ratio set up like this, we always had you add it up to parts. All right, so 4 plus 3 plus 2 plus 1 gives me 10 parts. All right, anytime you see a ratio, always add it up for the parts. All right, so now if I continue to read, it says determine the following arc and angle measurements. So they're asking me to find these 4 pieces here. First thing that I want to do, I know that arcs are these edges of the circle, right? They make up the whole thing. So if I follow this through, BC, CE, ED, and then all the way back from D to B. So it's giving me the entire circle, okay? Well, I know that in an entire circle, a full circle, that's 360 degrees. So just like we always did in the other unit, I'm just gonna add this on here with like a little star. You always divide by the total parts. Okay, so I know that 360 makes up the whole circle, but now I want to know what each little chunk is going to be. So if I divide it by 10, I get 36 degrees. Okay, so now if I come back to my circle, I know that BC was just one part. So BC was one part. 1 times 36 is 36. So I know BC is 36 degrees. I know that CE made up 2 parts, C to E. So I know that 2 parts, right, 2 times 36 is going to be 72 degrees. All right, so this is my degree measure for BC. This is my degree measure for CE. And then I'm just going to keep going with that pattern. So ED was 3 parts. So ED, well, what's 3 times 36? It's going to be 108 degrees. And then last but not least, my biggest part made up of 4 chunks here. So I know that 4 times 36 is 144 degrees. Okay. And now that I have filled out what each arc represents, I'm going to try to go ahead and answer those questions. So it's asking me what's the measure of angle BAC. All right, so if I look, angle BAC, I can see that this is a central angle because it's at the center of the circle. I know that central angles equal the arc that they're intercepting. So I can see that BAC, right, this little piece of the pizza right here, it's hitting 36 degrees. It's hitting that degree measure. So if the arc is 36, the angle is going to be 36. So I'm going to fill that in on the side. It's 36 degrees because that was a central angle. All right, so I know it equals the arc that it's hitting. What's the measure of angle DAE? Well, we have DAE. So I'm just going to highlight that out as well. DAE. This is also a central angle because it's hitting the center. And I can see that it's hitting this 108 degree section. So if this is 108, I know this angle is going to be 108 degrees. And again, they're equal because it's a central angle. All right, next, if I look at C, what's the measure of arc DB? Well, we already found the measures of the arcs, so hopefully C and D will be easy. So DB. So DB is this section of the circle right here, which is 144 degrees. We found it before. And then last but not least, what's the measure from C to E to D on that circle? So C to E to D. So I want to get this whole section of the circle. Well, I can see here that I'm hitting my 72 degree arc and my 108 degree arc. So I know that if I add my 72 and my 108, I get an answer of 180 degrees. But boys and girls, do you see that I didn't even have to add these numbers? We should have known it was going to be 180 because it's half a circle, okay? So we already went over on the first page that half a circle is 180. So I know this has to be 180 regardless of what these numbers are because it's half a circle. This is a diameter cutting it in half, all right? So let's just add that on here. I know it's 180 because it's not just half a circle, it's a semicircle. Might as well use that new vocab word since we just learned it. Okay, now if we go to the third page, and we look at example 4, it says in circle B, line segment AB is going to be congruent to line segment CD. So let's mark that AB is congruent to CD. Okay, now it's asking us to determine the arc measurements. Before I even look at these questions, I always try to ask myself, what else can I mark on that diagram? Is there anything else that's there to help me? Do I have any vocab words, that maybe they didn't give me in the question? So I notice right away that AB is a radius. Do you see another radius? Because I'm seeing not just one more, but 2 more. So B to A is a radius. B to C and B to D. These are all radii. So if this has 1 dash, I know BC gets a dash, and I know that BD gets a dash, because they're all radii. Okay, so that helped me a little bit. Now, what shapes do you see? Well, I see a semicircle from A to D, another semicircle, right, from A to C to D. It's not really helping me because there's no numbers right now. Oh my gosh, you guys absolutely nailed it. An equilateral triangle. I know that if all of these sides are equal, that means all the angles are equal. So that means there's 60 degrees in each angle. I'm going to go ahead and mark that. Then I'm just going to swoop it out here, right? Arc it out. Whoop. Okay. And I feel like at this point, there's only one other step that I can take. There's nothing else I can mark inside the circle. I think we've done it all. So now I'm going to try to mark the outside of the circle, those arcs, because that's what the question asked, the arc measurements. So now I'm going to use the vocab that we just learned on the first page to kind of help us out here. So I know that 60 is a central angle because it's the center of the circle. So this 60 degrees is formed by C and D. So I know from C to D, this section of the circle, it has to also be 60 degrees. Because again, this angle is central, and the central angle is hitting this arc, and they're equal. All right, that's just from the definition of the vocab word. Then if I keep going, okay, well, just like we said before, I know that the bottom half is 180 degrees, so I might as well add that on. And I know that the top half is 180 degrees. I'm gonna go ahead and just highlight that really quick. Okay, so I know that if this section is 60, that means that this leftover has to be 120 because together they make 180. All right, and now I'm gonna go ahead and try to answer some of these questions here. So if I look at part A, it's asking me what's the measure of arc CD? Well, C to D, we already found it was 60. I'm just gonna add that on. Part B, what's the measure of arc CAD? So again, in order, C to A, all the way to D. So I know CA is 120. And then I know A to D was 180. So when I add those numbers together, I get 300. So I know that entire arc is 300 degrees. And then last but not least, CDA. So I got to find that arc. C, D, all the way to A. So on that journey from C to D, I hit 60. And then from D to A, I hit the 180. So when I add those bad boys together, I get 240 degrees. All right. 5 and 6 are a little bit different because they require some algebra, which I'll go over in a minute. So let's kind of just jump in and go from and get started. All right, so if we look at example 5, it says in circle A, I know it's circle A because A is the center. It tells me that line segment BC is a diameter. So I'm immediately going to stop and just highlight that key word. I know I've said a few times now that diameter is a really important word, and we'll come back to it in a minute. I'm also reading and it tells me that the measure of angle DAC is 100, but I can see on my diagram DAC, it's already labeled as 100. So I'm going to skip past this and just continue reading. This is really important. It says if the measure of arc EC is going to be 2 times the measure of arc BD, we want to determine all this information on the side. All right, so I'm gonna go back and I'm gonna just start with that keyword diameter because I know I said that was important. So when I see the word diameter, there's a few other keywords that come to mind like radius, because I know the radius is half of the diameter and maybe that will help me when I'm solving, you never know. I also think of the word hypotenuse because I know if the diameter is creating a triangle, it's really a right triangle. All right, and that means that the diameter would be the hypotenuse in that right triangle. And then last but not least, I also think of the number 180 because I know a diameter creates half a circle, right? That semicircle. So I know that the bottom half is 180 and the top half is 180. So before I move on, I'm actually just going to highlight that out on my diagram. So I know that B to C on the bottom half represents 180 degrees. Maybe it'll help me, maybe it won't. We'll see. And I know that the top half from B to C also represents 180 degrees. So I'm just going to start off by marking those. And then if I continue reading, I know we already said that the 100 degrees is marked, so I'm going to skip it. And then this is the last important piece of information that I need to start solving the question. So I know that if I double arc BD, it's going to give me EC. And right now, I don't know anything about these arc lengths, so I'm going to start off by just filling in that arc BD is X. Because it looks like I know a little bit more information over here, so I'm going to start over here. So if I let BD equal X, then I'm going to mark that BD equals X. And I know that when I double it, whatever this answer is, when I multiply it by 2, it's going to give me arc EC. So now I know that EC is going to be 2x, whatever that answer was, okay? And now I've really used everything that they gave me in the direction, so I'm going to try to just jump in and start. So I'm noticing right off the bat that 100 is a central angle, and I can see that that central angle is intercepting arc DC, okay? So if this if this angle is 100, I know this arc has to be 100. They're equal, all right? And now I can see in yellow that I'm hitting X and I'm hitting 100. And I know that together these make, you got it, 180 degrees. So if this is 100, this has to be 80. So I'm gonna just start off by filling that in. And now that I know X is 80 degrees, now I can jump up top and fill that in. So I know that 2X, 2 times 80 is 160 degrees. So now I know 3 portions of the circle. I know what all of those angles are going to be, really those arc lengths. And now I can kind of jump in and I'm gonna see if that'll help me fill in any of these questions. So the first part is, what's the measure of angle BAE? Well, BAE is this angle right here. And I can see that it's hitting this arc, EB. All right, so it's the only arc that I haven't filled in yet, but I can easily find that arc because, again, I know that the top half in green makes 180 degrees. So if the right-hand side is 160, I know this leftover has to be 20, right? Because together they make 180. All right, and this is also a central angle like 100. So I know if the arc is 20, the angle has to be 20. So I'm gonna fill it in on my diagram, and then I'm also gonna fill it in as my answer on the side. All right, and now I'm gonna keep going. So what's the measure of arc EC? Well, arc EC is just this green portion right here, that bigger portion, and we already found it. It's 160 degrees, so I can just fill it in. And I don't have to show any work over here because I already showed my work on by the picture. All right, so I can skip that. And then part C, it says find the measure of arc DEC. So I have to go in order of the letters from D all the way to E, all the way to C. So I want to know what that big chunk is going to be. So I can see that I'm hitting this arc, which is 80, the arc of 20, and the arc of 160. So I'm gonna set that up on the side here. When I add my 80, my 20, and my 160 together, I get 260 degrees for my final answer. Okay, and then moving on to number 6, same thing, there's gonna be a little bit of algebra, but now you'll kind of expect what to do. So again, it says if I have circle A, and I know it's A because A is the center, line segment BC is a diameter. So again, I'm going to stop and just highlight that because when I see the word diameter, there's other keywords that I should be thinking of as well. I know that 2 times the measure of arc CE, it's going to get me the measure of arc ED. So that's important. We'll come back to it. And I know that line segment BC is parallel to line segment DE. So there's a lot of good information going on here. So I'm going to stop before I even look at what I'm supposed to solve for. I want to just look at all this information that they gave me and kind of evaluate what to do. So again, diameter is a key word. When I see diameter, I should be thinking of a radius, which I don't have any of those in this diagram, except AB and AC. And I don't know the measure of either one. So I'm going to skip that word for now. I should be thinking hypotenuse. But this diameter doesn't make a triangle anywhere, so I'm going to skip that as well. So I'm seeing the 180, which I can always mark for the most part, so I'm going to go ahead and do that. So I know that the bottom half makes 180 degrees, so I'm just going to go ahead and mark that in yellow. And then I know that the top half also makes 180 degrees, and I'm going to go ahead and mark that in green, just because I have 2 different colors. All right. So now that I've labeled my diameter in some way, now I'm going to keep reading. I know that 2 times CE, well, I don't know what CE is to multiply by 2. So I'm going to make CE X because I have no idea what it is, which means I'm going to make this arc X as well. And I know that when I double that arc, it's going to give me ED. So now I know that arc ED is 2X. Okay, so now I use this middle piece. Now I'm going to keep going. I also know that these 2 line segments are parallel. So I'm just going to write that as a refresher in case anybody forgot. And I know that parallel lines form, you guys got it. Oh my gosh, alternate interior angles. So I'm just going to label that alternate interior angles. And who remembers how I find those alternate interior angles? Oh my gosh, you guys are so smart. Yes, I have to make that letter Z. So I can see here that they've already marked that those lines are parallel. If you guys want to go ahead and just mark it a little bit extra, for that practice, I would do that. But now I'm going to make the Z. So I start on my parallel line, make my way over, so I end on my parallel line. So now I know that whatever the measure is of this angle, this one has to be the exact same thing. So I know that if this arc is x, I know that this arc has to be x. Because whatever this angle is, this is the same. So whatever this arc is, this one has to be the same. All right? And now it might look like they didn't give us enough information to solve, but really they did, because if you remember, this entire arc is 180 degrees. So now if I take my x, my 2x, and my last x, right, x, 2x, and x, if I take all three of those arcs and I add them together, it should make 180 degrees. So when I add them, I get 4x equals 180, and then when I divide by 4, I get 45. So now I'm going to go ahead and just fill that in. X is 45, x is 45, and I know that 2x, so 2 times 45 is 90. Okay, so now I know the degree measures of all of these arcs. And now I'm finally going to go ahead and actually read the question. So the question says determine the measure of angle CDE. So again, CDE was this angle that we had marked before. And I know that this is an inscribed angle because it's on the circle. So inscribed angles are half of the arc that they intercept. So now I just got to think, well, what's half of 45? So again, I'm just going to set myself up here. So I'm going to write the measure of angle CDE. It's going to be half of 45, which is 22.5. And again, I'm getting that answer because I know this is an inscribed angle, which tells me it's half the arc. All right, and we are done. You guys are absolutely crushing it every week. Please be clicking geometry in Canvas and then clicking assignments, all right? Some of you I know aren't turning in every single assignment. You should be emailing us if there's anything going on that we should know about. Aside from that, we post lessons every single day, it's just like we're doing right now. So please make sure you're getting all of that work done. Stay safe. Make sure you guys are still getting some exercise in, going outside, and reaching out through email if you need us. All right, miss you.